Okay, this is section 4.1 for Algebra 2, Mr. Kuhne's class. Sorry I can't be with you today, and we're going to give this a try and see how this works. We're going to be graphing quadratic equations today. Quadratic equations, if you remember, are parabolas. We're going to be doing these in standard form, not vertex form as we did earlier. Standard form is written so y equals ax squared plus bx minus c. First thing we're going to do here is we're going to find the y-intercept. Now we all know that the y-intercept is on the y-axis, and if I need to find the y-intercept, well, that's pretty easy actually to do that, because anywhere on here the x-coordinate is 0. This would be 0, -3. This would be 0, comma 4. This would be 0, comma 5. This would be 0, comma 1. So the x-coordinate is always 0 on the for the y-intercept. So I'm just going to plug it in. 0 squared, plug in 0 for the x, minus 4 times 0, plus 3. Oh, that's pretty easy to see that it's going to be 3. So I've got my first point, 0, comma 3. I'm going to graph that point, 0, 1, 2, and 3 right there. The next thing I'm going to do is I'm going to start at the vertex. The vertex is the tip of the parabola, bottommost part or the topmost part. It's the bottom of the valley or the top of the hill. It's the minimum or the maximum. First thing we're going to do is we're going to find the x-coordinate for it. Then we'll go about finding the y-coordinate in just a moment. To find the x-coordinate, you take x is equal to negative b over 2a. Now the first number is a, the second number is b, the third number is c. It's only a, b, and c if it's written with the x squared first, the x to the first power second, and just the constant third. So negative b over 2a, negative b, well that means we're going to have negative, b is negative 4, so negative 4 over 2, and the a is the 1 in front there. So those two negatives are going to make that positive. 4 divided by 2 is 2. So I'm going to write that down here in my t-chart. I'm going to pick x values around the vertex, like 1 and 0 and negative 1. And I'm going to pick 3 and 4 and 5. So this is my vertex. I'm going to pick numbers around it. Now I'm going to find the y values. Find the y values, pretty simple. Just plug them in. Well, we already did this one. If I plug in 0 into here, I'm going to get 3. If I plug in negative 1 squared is going to be positive 1. That's going to give me a positive 4. Then a positive 3. So 1 plus 4 plus 3 is going to give me 8. If I plug in 1 squared is 1. Minus 4 times 1, that's going to give me negative 3 plus 3. Oh, that's going to give me 0. That's kind of nice. Let me plug in 2 this time. 2 squared is going to give me 4. 4 times 2 is negative 8. So I've got negative 4 there plus 3. It's going to give me negative 1. Now let me plug in 3. 3 squared is going to give me 9 minus 12. Plus 3, well that's going to give me 0 again. And I'm going to plug in 4. 4 squared is 16. Minus 4 times 4, well that's minus 16. So I'm right back where we started. We've got 3 here, plus 3. And you can kind of see a pattern here. Since this one's a nice whole number, the vertex is on a whole number, it should be symmetrical around it. Just like that. And so if I plug in 5, well, it should be 8, but let's just do a quick check. 5 squared is 25, minus 20 is 5, plus 3 is 8. So now I'm going to graph these points. Negative 1, comma 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, comma 3, already got that one. 1, comma 0. 2, comma negative 1. 3, comma 0, 4, comma 3, and 5, comma 8. So now that we have that, we're going to connect the dots. It's going to make a nice, lovely parabola. So I've connected the dots to form the parabola. Is this concave up or concave down? Well, it's concave up, clearly because the ends are pointed up. So this is going to be concave up. And is the vertex a minimum or maximum? The vertex right here, this is the vertex. And it's at the bottom, so it's going to be a minimum. Next question we have, what's the domain and the range? Well, the domain is all the x values we can plug into it. There's nothing to say we can't plug in huge negative numbers or huge positive numbers. We can plug in anything we want to. So the domain is all real numbers. If you want to write it in interval notation, it's going to be negative infinity to positive infinity. The range. Now you remember the range is all the y values that can come out of this. Well, it's going to be going up forever here, so I can use all the positive y values are going to work, and we use all the y values down here to 0. We even use -1, but we don't go below that. So the y values here, kind of from here, if we're to squish this over, it's kind of from -1 here all the way up. So the range is going to be, if you want to do it as a inequality, it's going to be y is greater than or equal to -1. Or if you want to do it in interval notation, it'd be -1 inclusive to infinity. All right, the next problem here. We're going to do the same thing. We're going to be graphing y equals -4x squared plus 2x plus 1. First thing we're going to do is find the y-intercept. Find the y-intercept somewhere along here, which means x has to be 0. So y is equal to -4 times 0 squared plus 2 times 0 plus 1. Oh, another easy problem. It's going to be 1, so 0, comma 1. So there's my y-intercept. Next thing I'm going to do is find my vertex. To find the vertex, it's -b over 2a. Well, this is my a, this is my b, this is my c. So let's just fill it in. -b, -2 over 2 times -4. Well, those are going to cancel out. 2 negatives are going to cancel out, and that's going to make it positive 1/4. And I'm going to pick numbers around it. Now, I could pick fractions if I want to, but I really don't. So I'm going to have 1/4 here. I'm going to pick the next number smaller, next whole number smaller, which is going to be 0. I'm going to pick the next bigger number, which is 1, 2, and we're going to go with -1 as well. All right. So I picked x values around the vertex. Next thing I have to do is find the y values. So if I plug in -1 into -4x squared plus 2x plus 1, with a little bit of work, it's going to give me -5. 0, well, we already did that one, so 0, comma 1. This won't always happen that you find the y-intercept so easily. Now we're going to plug in 1/4 into this equation. After a little bit of work, I find out it is 1 and 1/4. And if I plug in 1 into this equation, 1 squared times -4 is going to be -4, plus 2 is going to give me -2, plus 1 is going to give me -1. And if I plug 2 into the equation, it's going to give me -11. Now some of you might be wondering, up here we saw that the numbers were symmetrical on either side of the vertex. That happened because the vertex was on a whole number. If That's not the case down here. It's on a fraction. It's on 1/4. So we're not going to have a nice symmetrical graph, but it should still form a parabola when we're done with it. So let's see what happens here. Trust the process. So we got 0, 1, we got -1, -5, and make our point there. 1/4, well, there's a half, there's a fourth, so 1 and 1/4, that's going to be really close right there, but that's okay. Then we're going to have 1, -1, and we're going to have 2, -11. 5, 6, 7, 8, 9, 10, 11. Now that may look kind of weird, but it is still forming a parabola. If we had chosen a number that was just 1/4 bigger, it would be symmetrical. It would be symmetrical. So if we had chosen, for example, 1/4 plus 1/4 is 1/2, on the other side of this, it would have given us 1. And that would have worked just fine. All right. Connected points to form a parabola is a concave up or concave down. This one right here is concave down. Concave down looks like a frown. Concave up looks like a cup. It's concave down because both the ends are going down. Is the vertex a minimum or a maximum? Well, that's as high as you can go, so the vertex is a maximum. And the vertex here is going to be 1/4, 1 and 1/4. Or if you don't like it that way, you can write it as a decimal 0.25 and 1.25. And then the domain and range. Now, once again, the domain are all the x numbers that we're allowed to plug into this function. We can plug any number into this function, so the domain is going to be all real numbers, or in interval notation, -infinity to +infinity. The range on this function, the range, well, we got a bunch of negative numbers. The biggest number we can get out of this is going to be 1 and 1/4. So it's going to be all y's less than or equal to 1 and 1/4, or 1.25 if you prefer that. If you want to write it in interval notation, -infinity to 1 and 1/4.